5, Day 1, Ratios and Proportions. We have seen ratios before. A ratio is a comparison of two quantities using division. So if you think of what it looks like when you have something divided by something else, this is just really a fancy word for a fraction. There's 3 ways to write a ratio. For example, if I wanted to compare the number of apples I have to the number of bananas I have, I could say apples to bananas and write it as a sentence. I could use a colon and compare the number of apples to the number of bananas. Notice I still say it apples to bananas even though I write it with a colon. Fraction, same thing, the number of apples to bananas. Okay, whatever comes first in my sentence is what's going to be the numerator on my fraction. And then something super important to remember is to always reduce our ratio. So once we write it as a fraction, we want to make sure we reduce those values. Okay, all right, let's look at some examples. We're going to write them in all 3 formats. I like to start with the fraction, that way I can see it easily to reduce it if I need to. So starting with number 1. In Logan's High School, there are 190 teachers and 2,650 students. What is the approximate student-teacher ratio? So the way they've asked me, student-teacher, since student is listed first, that's going to go in my numerator, and teacher is listed second, so that's going to go in my denominator. So the number of students I have is 2,650. I'm going to put that over the number of teachers I have, which is 190 teachers. And then I want to make sure I reduce that. If you hate reducing and you're unsure of your reducing skills, use your calculator. 2,650 divided by 190 is going to reduce to 265 to 19. Once I have it written as a fraction, then it's easy to change that to a sentence, 265 to 19, and then with a colon, 265 to 19. So there are my 3 different ways to write that ratio. Let's look at the next one. In a schedule of 6 classes, Maria has 2 elective classes. What is the ratio of elective to non-elective classes? So since elective is listed first, that's going to go in my numerator, and non-elective is written second, so that's going to go in my denominator. So how many elective classes does Maria have? She has 2 elective classes. That's going to go in my numerator. How many non-elective classes she has? It's real tempting to go, oh, my numbers are 2 and 6, so that's what I'm going to put here. But she has 6 classes, not 6 non-elective classes. She just has 6 total classes. 2 of them are elective. That means 4 of them are non-elective. Okay, so sometimes you have to pay attention to what you're being asked compared to what you've been given. Okay, that one, when I reduce that, I'm not sure that I need my calculator for that one. That one is 1 to 2. That's as a fraction. We can write it 1 to 2 or 1 to 2. As a fraction, as a sentence, and with a colon. Okay, let's look at this last one over here, number 3. 1 ounce of cheddar cheese has 9 grams of fat. 6 grams are saturated fat. What is the ratio of saturated fat, oops, I'm going to switch colors, saturated fat to non-saturated fat? So since saturated is listed first, that's going to go in my numerator. Non-saturated is going to go in my denominator. So I can see there are 6 grams of saturated, so that's going to go on top. Non-saturated, they didn't tell me, but I do know I have 9 total grams. 6 of them are saturated, that means 3 of them are non-saturated. Now, when I put this in my calculator, I'm just going to get a 2. But a 2 is not a ratio because a ratio has to compare 2 quantities. That's only one number. So it has to be 2 over something. So we know this is going to be 2 to 1. So when I read it, I'm not going to read it as 2. I'm going to read it as 2 to 1. Just like when I read this one over here, I'm not going to read it as 1/2. I'm going to read it as 1 to 2. This one is 2 to 1, or we could write it as 2 to 1, or we could write it as 2 to 1. There's my fraction, there's my sentence, there is with a colon. Okay, let's look at something new. We did ratios in middle school math, but let's look at something new, extended ratios. If I have more than two things to compare, we're going to compare three or more quantities using an extended ratio. So A to B to C, that means I can compare A to B, or B to C, or A to C. Okay, let's write the angles of the triangle as reduced extended ratios A, B, C. Okay, so it does say reduced extended ratios, and then it tells me I want to do A first, B second, and C third. So I can see A has a measure of 35 degrees. To B has a measure of 100 degrees. To C has a measure of 45 degrees. Okay, so now what can I divide all of these by to make sure, because my calculator doesn't reduce ratios, what can I divide all of these by so that I can reduce this? So 35, 100, and 45, those are all divisible by 5. They're also all degrees, which means I can divide them all by 5 degrees. When I divide them by 5 degrees, my degrees are going to cancel, so I'll just have the number 7. My degrees cancel here, so I just have 20. And my degrees cancel here, so I just have 9. So 7 to 20 to 9. 7 to 20 to 9 is my reduced extended ratio of the angles in this triangle. Let's look at this triangle over here. If you want, you can pause the video and work them out together and then check your answers when you're done. All right, so let's look at this one. We're going to do A to B to C. A is 80 degrees. B is 60 degrees. And then C is 40 degrees. What can I divide all of these by? Well, you might notice that they're all divisible by 10 degrees. When I do that, I get 8, I get 6, and I get 4. But some of you might have said, wait, but hold on, those are also divisible by 20. If I would have divided them by 20, I'd have gotten different answers. When you divide, you also want to then look at your numbers and go, can I divide still? Is there still anything? Well, these are all even. So yeah, I can still reduce this. This is not fully reduced. These are all divisible by 2, which is going to give me 4 to 3 to 2. And then 4, 3, and 2, there's nothing else I can divide those by, so that is my final reduced extended ratio. Now, had I divided originally by 20, I would have gone straight to my 4, 3, and 2. But I did want you to see that sometimes you want to check it to make sure you don't need to divide again. Okay? Let's see how we can use this idea of extended ratios to work backwards to find angle lengths or side lengths. All right, the ratio of the sides of a triangle are 7 to 8 to 13. The perimeter of the triangle is 84 centimeters. Find each side length. If I were to sketch this triangle, I know the ratio of the side lengths are 7, 8, and 13. So it's going to be scaling because these are all different. So I'm going to draw myself a little scalene triangle. I'm going to put the shortest side on the shortest side, the medium side on the medium side, and the long side on the long side. And we're talking about the perimeter here. And I know I find perimeter of a triangle by adding up the 3 sides. So if I add 7 plus 8 plus 13, that would normally give me my perimeter of this triangle. My perimeter is supposed to be 84 centimeters. However, 7 plus 8 plus 13 does not make 84 centimeters. But remember, this is the ratio of the sides. This isn't the actual sides, which means this has been reduced. It has been divided by some common value. 7, 8, and 13 have all been divided by the same number, right? Like up here, these were all divided by 5 to get here. These were all divided really by 20 to get here. So to work backwards to figure out what my original numbers were, the 7, the 20, and the 9, to work backwards, I'd have to multiply by the 5. 9 times 5 gets me back to 45. 20 times 5 gets me back to 100. And 7 times 5 gets me back to 35. I just have no idea what I need to multiply by. So since I don't know what I need to multiply by, I'm going to call it x. So I'm going to really say this is 7 times some unknown value x. This is 8 times some unknown value x, and this is 13 times some unknown value x. I'm going to combine these like terms. 7 plus 8 plus 13, x is going to give me 28x equals 84 centimeters. Use my division property of equality to divide both sides by 28. That cancels out, and I'm going to get x equals 84 divided by 28. 28 is 3. Now, since I have 84 centimeters divided by just 28, and it's not 28 centimeters, my centimeters doesn't cancel out. I'm still going to write it. So my x, now we know my x is 3 centimeters. So if I replace each of these x's with 3 centimeters, then I'll be able to do what I'm asked to do, find each side length. 7 times 3 centimeters is going to be 21 centimeters. 8 times 3 centimeters is going to be 24 centimeters. And 13 times 3 centimeters is going to be 39 centimeters. We can check this because 21 plus 39 plus 24 equals 84 centimeters. And then we feel confident we did it correctly. Let's look at the next one. If you'd like, again, you can pause the video and discuss with your table on how you would do this problem. Then, once you're ready, you can press play to go on. All right, let's go over this one. This time I have the ratio of not sides but angles. So when I draw my triangle, it's going to be a little bit different than when I drew this one. I could draw the same triangle if I wanted to, because these are still all different, which means this would still be scalene. But these are the angles, which means instead of writing them along the side, I'm going to write them inside the angles. 3 for my smallest angle, 4 for my medium angle, and 5 for my biggest angle. Okay, and then remember the next thing I did is I added them together, and they equaled, up here, they equaled the perimeter. My 3 plus my 4 plus my 5 equals, well, the angles don't add up to a perimeter, right? The sides add up to a perimeter. But I know in every triangle, angles of a triangle, they always have the same sum. And that sum is 180. So I know that this should equal 180. Well, but 3, 4, and 5 clearly do not add up to 180. So again, I'm going to have to do the same thing I did before. I'm going to have to figure out what I need to multiply my 3, my 4, and my 5 by to get up to this 180. So I have to find these values for these x's so that when I add these together, I get 180. So that is going to be 12x equals 180. We're going to divide both sides by 12. Division property of equality, and we'll get x equals 15. Once I know what x is, I can plug it into each of these. 3 times 15 is 45 degrees. 4 times 15 is 60 degrees. And 5 times 15 is 75 degrees. So these are my 3 angles in that triangle. You can test it because when I add these together, I should get 180 degrees in that whole triangle. Okay, let's look at the next one. A proportion. A proportion is an equation, so you'll see an equal symbol there, stating 2 ratios. Remember, ratio is just a fancy word for fractions, so 2 fractions are equal. So an equal fraction to an equal fraction. A proportion, you may or may not remember from middle school, a proportion can be solved using cross multiplication. Your middle school teacher may have called it the butterfly method because when you circle across, it kind of looks like a little butterfly. But in high school, we generally refer to it as cross multiplication. A times D is going to equal B times C. Let's practice some cross multiplication. All right, so again, I'm going to cross multiply. I'm going to do 3 times x is going to equal 2 times 24. Three times x is 3x, and that equals 48. Then we'll go ahead and divide both sides by 3, our division property of equality, and x is going to equal 48 divided by 3 is 16. On the next one, again, I'm going to cross multiply. I usually like to start where I see an x. So I'm going to multiply 100, or x times 100. Equals 5 times 28. That's going to give me 100x equals 140. If I divide both sides by 100, division property of equality, that is going to give me x equals 140 divided by 100 is 7/5. You can leave it as 7/5, or if I hit menu 2-1, I get 1.4. Either way is perfectly acceptable as a decimal or a fraction. Generally, if the fraction or the decimal is one that goes on forever, it's irrational, then we usually will leave it as a fraction. Okay? All right, let's look at the next one right here. Again, I'm going to cross multiply. Notice some of you may go, why are you writing this step? You can just totally skip this step. You can do 3x equals. I can just do that multiplication. The reason I do that is for mostly situations like this. I don't always do it for here, but in my notes I like to show every step. But in this case, if you have a plus or a minus in a denominator or a numerator, then I definitely would not skip this first step here, okay? Because otherwise you might end up with 8x minus 3, but it's really 8 times that whole thing, x minus 3, and we're going to have to remember that we're going to need to distribute that 8. And then here, 3 times 5, that one you could, if you wanted to skip and go straight to 15, you could. But I like to make sure I write it out if I have that plus sign so that I don't forget that that 8 has to go to both terms there. And I end up with 8x minus 24 equals 15. I'm going to add 24 to both sides. When I do that, I'll get 8x equals 39. When I divide by 8, I'm going to get x equals 39 divided by 8. That's not going to reduce, I don't think, but we can check it. 39 divided by 8 is, 39/8. Again, if you wanted to turn that into a decimal, menu 2-1, 4.875. Some of you may have been shown when you have that 39 divided by 8 and you're like, oh, it doesn't reduce, to hit Control Enter, and that will give you your decimal. And 90% of the time it will, but depending on how you use your calculator, sometimes this gives you a wrong answer. So I would just be real careful when using that. And when you go to Menu, this second option here, Number, gives the very first two are real helpful if you need to convert something to either a decimal or if you need to take it backwards to a fraction. These two here are really good at doing that. The first one, will take your fraction and turn it into a decimal. The second one will take your decimal and turn it into a fraction. Okay, so that's just kind of a helpful little hint there. All right, let's look at that. Oops. Let's look at that last one. I'm doing all sorts of weird things with my calculator there. Okay, our last one over here. Again, we're going to start by cross multiplying. I have x's on both sides on this one, so you kind of just get to pick which one you want to start with. I'm going to start with this one and do 2 times 4x equals, and then we'll do the other side. Again, remember that 5 is going to have to multiply to both of those things. So that's going to be 5 times the whole thing, x plus 3. 2 times 4x is 8x. Distribute the 5, so that's going to be 5x plus 15. I have x's on both sides of my equal, so I can't just add them together because they're on different sides of the equals. So to move them to the same side of equals, I have to use my subtraction property of equality to get my x's together. That's going to leave me with 3x equals 15. Division property of equality, divide by 3, and x is going to equal 5. Okay. All right, so now we have written some ratios and we've solved some proportions. Now we're going to write proportions, so just 2 equal ratios, so that we can solve them and make some predictions. Let's look at A. Jimmy conducted a survey of 50 students driving to school and found that 28 owned their cars. If 755 students drive to school, predict the total number of students who own the cars. Okay? All right, so first, Jimmy did a survey. He asked 50 students that drive to school if they own their car or not, and 28 of them said, yes, I own my car. Okay, so then he said, all right, well, I have 755 total students that drive to school. I wonder if I can predict how many own their cars. Okay, so the first thing I have to do is figure out what 2 things are my numbers representing. So this 50 is 50 students, and the 28 is 28 students. So it's not students to students. What are those students doing is what I need to know. So these 50 students are driving to school. So I have students that are driving. And then 28 of those students, they actually own that car. It's not their mom or their dad or their grandma's car. It's their car. So 28, my other number, represents students who own their car. So these are my 2 things, my driving students and the number of those that are driving that own their car. So those are my 2 quantities. Now I need to set them up as a ratio. Well, I kind of already did, right? If I just draw a line right there, driving over owning. If I had written this the other way around, owning over driving, that would be okay. All right? You just have to make sure that when you set up your ratios, you always have driving on top and owning on the bottom, or if you flip this over, owning's always on the top and driving's all the way up the bottom. So own, 50 students drive to school. Driving was going on top. Over, own, 28 of those 50 own their cars. Then, if I look at my next scenario, 755 total drive to school. Driving, 755. How many of those own their cars? I don't know. That's what I'm trying to predict. Okay? These 2, for prediction purposes, should be equal. So then I'm going to cross multiply. Let me grab my calculator. Okay? 50 times x, 50x, equals 28 times 755. Gives me 21,140. Division property of equality. And x is going to equal, divided by 50, 2,114 over 50. Let me save this real quick. I'm having some problems. Okay, so that's not really, oops, over 5. I have the wrong thing there. Over 5. Over 5. All right, so that doesn't really tell me like how many kids is that. I don't know how many students that is, 21,014 or 2114 over 5. So again, I'm going to turn this into a decimal. Menu, number, convert to decimal, and I get 422.8. So 422.8 students drive to school or own their cars is what I'm predicting. But I can't have 0.8 of a student, right? People are whole people. No matter what, a person is a whole person every single time, right? People are whole people. So if I were to try to predict, do I think this would be 422 people or 423 people? I would round, since it's 0.8, I would say we're more likely that that 23rd person, that 423rd person probably does own that car if this was a good survey. So I would predict that 423 students own their car. And again, that's a prediction, which means that's not necessarily true if I really asked all 755 students. Okay? All right, let's look at this next one, part B. All right, we have students netting butterflies. That just means they're catching them in a net. They're recording the number that have tags on their wings, and then they're letting them go again. Students netted 48 butterflies. 3 of them had tagged wings. Okay, I'm going to mark that. So we netted 48. 3 of those had tags. Okay, then over here, predict the number of butterflies that would have tagged wings out of 100 netted. So I'm going to predict the tags if I net 100. So let's think about what our two quantities are, right? In this case, I am netting butterflies and I'm checking for tags. So I'm going to have netted and tagged. I'm going to, just for fun, put tagged on the top. I don't know where my letters are going. Let me try saving again. Sometimes that helps when my images start deleting. Be patient, please. Let's try it again. Okay, so I've got tagged, and we are looking at how many we've netted. Okay, I am back. I had to restart everything, so bear with the awkward transition there. Okay, so we have tagged wings and netted butterflies. Butterflies that we have caught in a net. So I'm going to do tagged over netted as my two things. I can see I netted 48. I'm going to put that on the bottom because that's where netted is. 3 of those were tagged. Then I'm going to predict how many are tagged. So that's going to be my X out of if I net 100. So to make this prediction, I am going to set these two ratios into a proportion equal to each other and cross multiply. 48x equals 300. I'm going to use my division property of equality. And x is going to be, I closed my calculator. It's going to take a minute for that to come back up, but it's going to come out to 6.25 while we wait on that. So now if I want to predict how many butterflies, if I've got 6.25, 0.25 is not even like it's a fourth of a butterfly, right? So there's not a good chance that we're actually going to catch that 7th butterfly. So I am going to say we're going to probably net or probably only have 6 butterflies that are tagged. So I'm going to predict 6 tagged butterflies. Now, that's not to say that if we net 100, maybe we'll have 10, maybe we'll have 20, maybe we'll not have any, right? This is just a prediction based on when I netted 48, okay? All right, so let's look at this last one. June randomly surveyed 30 students in her class and found out that 18 of them had a dog or a cat for a pet. If 870 students in June's school, predict how many students have a cat or a dog. Okay, so she asked June, talked to 30 students in her class. Okay, 18 of them had a dog or a cat. Now she's going to look at the whole school. There's 870 students in the whole school. We want to predict how many have a cat or a dog. Okay, so the two things we're comparing are going to be students. This time it is students that we're asking, right? And then how many have either a dog or a cat? So that's how I'm going to set up my ratio. Students to basically I have a pet, a dog or a cat. Okay. All right, so when we asked 30 students, 18 of them had a dog or a cat. If I ask 870 students, I wonder how many have a dog or a cat. So we can use proportions and cross multiply to make a prediction. So 30 times x equals 870 times 18. Oops, I need to hit number 1, menu, and a calculator. Did all that without a calculator. 18 times 870. That is 15,660. I'm going to divide both sides by 30. And that's going to give me x equals, let's see, 15,660 divided by, notice when I just hit divide rather than type that whole number in, it says take the last answer, that's that little A and S, and all I did was hit the divide key. And I'm going to divide that by 30. And it's not even a decimal, it's not even a fraction, it is 522. So I'm going to predict that 522 students have a cat or a dog. All right, hopefully that helped you out with ratios and proportions and writing them. And thank you so much for watching. Don't forget to complete your independent practice in Schoology.